Good evening, YouTube. Welcome back to the channel. Back tonight with another Python Koans video. So, hope everyone is doing well. Happy Sunday. Getting ready for another work week. Hope everybody had a good weekend. I know I did. It was very busy with lots of kids' athletic activities. Had some friends over last night, which was fun. But back into studying mode. So here we go. Let's get back into it. This is around episode 7. I think we're close to halfway done, if not a little bit further beyond halfway. And so this should all be familiar to you at this point. All right, so where were we? We are in the group of Koans called Thinking About Methods. And we are failing on a test called Test Calling with Variable Arguments Has Damaged Your Karma. And that is right here. So we want to go to the aboutmethods.py file, line 64, to see where the failure occurred. And we've completed 76 Koans, 8 out of 37 lessons, so only 25%. We are not really close to halfway. So it's a little out over my skis on that one. Let's do Command T, aboutmethods.py. And it said that we were at line 64. So let's jump down there. Oh, no, maybe faster to scroll. Okay, so this is the method that failed for us. So we've got a method here on line 60, defined as method with variable arguments, okay? And it returns the arguments, args, okay? So it's going to return whatever we pass in as the arguments to the method. Okay, sounds good. So test calling with variable arguments. All right, so assert equal. When we call this class method, which I believe is what is happening when we call self dot something. Anyway, when we call this with no arguments, what does it return? I'm going to assume it returns an empty array, an empty list. All right, let's see what next, or maybe an empty tuple. I bet that's more like it, but we will find out, see if I'm wrong. On line 65, we're saying self assert equal 1, okay, and then we see that the method was called with a single argument of a string, and what was returned was a one-item tuple, and we know that it's a single-item tuple based on that trailing comma, which we said last video looks a little weird. All right, so I don't think there's anything to do here. I could be wrong, but I think this is just kind of like showing us how it's done. And finally, assert equal, what are we going to get back if we pass two arguments, the string 1 and the string 2, to the method with var args? I think we'll get a tuple back, not a list, not the number 90. A tuple back with the string 1 and the string 2 inside. So now I'm going to save the file and jump back over to the runner and see how far we got. So we have now passing test calling a variable with arguments. Test which does not return anything has expanded our awareness. I don't see test which does not return anything. Yeah, that's weird. I don't know why that's already passing. But anyway, let's go now to line 77. Method with default var args. Yeah, okay. That's weird. I don't know why it showed up there. All right, same thing. Okay, let's see. Line 70. We have a new function, a new method, and it's called function with the same name. And function and method are synonyms, FYI. Function with the same name. All right, so this function takes arguments A and B, argument A and argument B, and it returns the sum of those two values that are passed in, okay? Line 73, a new function, test functions without self-arg are global functions, okay? So we've got something that has to do with scope, okay? So functions without a self argument are global functions, all right? And then within that function, we have redefined function with the same name without passing in the self argument, okay? Return a times b. And then we have an assertion, assert equal something, function with the same name, 3, 4. So the question becomes, which function is being called here? The first definition of it, or the second definition of function with the same name? Is it going to be a multiplication or a addition? Based on what I know about scoping, I'm going to assume that it's going to be the multiplication one that's being called here. Why? Because we're calling the assertion like within the function definition itself almost. And therefore, I think like the most close, but I guess most local version is the one that's going to be called. And plus there's no self being passed in, but let's see. I'm not really that positive. I'm going to say 12 because 3 times 4 is 12. So let's run the test again and see what we came up with. Okay, that was correct because we've moved on to the next test. So I wonder if we pass in self 3, 4, if this one gets called. I did not want to do that. 77, blah, blah, blah. Curious. Type error. Okay. Oh, you can't even do that. Okay, so that makes no sense. It only expects the 2 functions. All right, so basically, test functions without self arg are global functions. Okay, good to know. So that must expand their scope to be available outside of a class, maybe just within the entire app running runtime. They're available if you create them like on line 74 here without the self variable passed in or argument passed in. All right, line 79. We say test calling methods in the same class with explicit receiver. Okay. So we've got a new definition of function with the same name. It takes A and B. It does not have the self argument passed in, and it returns A times B. Test calling methods in the same class with an explicit receiver. So we have assert equal self function with the same name 3, 4. I think this must be also 12. Line 83. Oh, that was wrong. I wonder, could this be 3 plus 4? And if so, why? Let's see. What is different about, oh, look, this is what's different. So in this assert on line 83, we call self dot function with the same name. And this version of the function with self passed in as an argument was called was the one called to complete the calculation. This one here, we don't say self dot function with the same name, and therefore this version was called. So there's a way with the use of self to determine the scope, like which you could have two functions with the same name apparently, and one could be local to your class and the other could be global. And the way that you differentiate and call one or the other, despite the fact that they have the same name, is through this manipulation of the self argument. All right, so that's kind of cool. So let's see, 83, does it pass if we throw in 7? Yes, it does. So now we're down to 96. All right, so we've got another method, another method with the same name, all right, and it takes the self argument and returns 10. And then we've got some kind of thing here where a variable linked to overlapped method is set to another method with the same name, which is that function, okay? Then we define another method with the same name again in the same way, and this time it returns 42. So, line 95, test that old methods are hidden by redefinitions. Okay, so we are calling self dot another method with the same name, and I'm going to assume based on this title of the test that it's going to return 42. Old methods are hidden by redefinitions. On line 92 here, we redefined another method with the same name. So that's what I'm thinking there. Test that overlapped method is still there. Okay, I'm going to assume that when we call self link to overlapped method, which was defined, which was set here, and it was set to the value or whatever was returned by another method with the same name in its most recent form prior to that. In that case, it was returning 10. So I'm going to assume at this point, when we call that variable, the value is what was returned by another method with the same name at the time that that variable was set. And at that time, it returned 10, not 42. So let's see. All right, we are up to 107. So I think that was correct. Sweet. All right, now we got some more. Let's see. We have empty method. All right. We've got empty method where we pass it only self, so nothing, and it just returns pass, okay? Test methods that do nothing need to use pass as a filler, okay? So they need to use pass that does nothing, assert equal something, and then what do we get back when we call empty method? I have no idea. Maybe we get pass back. That really doesn't mean anything. Maybe we get nil back. Let's see what it does. Nil is not defined. Maybe we get true back. Oh, maybe I need to capitalize nil. No. True. Let's see, try true. All right. It looks like none. All right, at line 107. Okay, so when we define an empty method that does nothing, we need to say pass, apparently, use this keyword to make it do nothing. And then when a method is called that does nothing, and I guess this password is used, it will return none. So test methods that do nothing need to use pass as a filler, okay? Assert equal none, all right, and that was correct. All right, next one, line 109, test pass does nothing at all, okay? You shall not pass, assert equal, still got to this line, does not equal none. So test pass does nothing at all, okay? You shall not still got to this line does not equal none. What? So pass does nothing at all, okay. True? Maybe? Yeah, it was true. So still got to this line does not equal none. You shall not. Oh. So we are inside a method definition. And in that definition, we are calling an assertion. And basically, what it's saying is we just skip right over this past line. It does nothing. It doesn't stop us. It doesn't stop the flow. It doesn't throw an error. We just make it to the final line of this method's definition. And that's an assertion that basically proves that we reached it. Okay. Number 118, line number 118. All right, so we're going to create a one-line method, all right, and return the string Madagascar. All right, so the thing about this is obviously we can create one-line methods, an entire method that exists on one line that doesn't indent down and over 4 spaces. All right, test no indentation required for one-line statement bodies, okay. So we call the one-line method, no indentation is required. What is returned? That's going to be the string Madagascar. Let's see if that works. All right. That worked. Okay, so we're down to line 30. So basically all this is saying is like you can write a method on one line that has a return statement, and you don't have to worry about doing this 4 space indentation like you do if you were to create a new line. All right. Next up on line 125, a method with documentation. All right, so this is on line 25, creating a new method called a method with documentation. And in the body of that method, we have first a string. A string placed at the beginning of a function is used for documentation, okay? And then it returns the string, okay. All right, so test the documentation can be viewed with the doc method. All right, so we've got an assertion, but this time it's an assert regex, where we call our method, a method with documentation, and then we call the method dot underscore underscore doc on it, and that is going to return a regex. All right, so a string placed I don't know if that's how we do this. Okay, there's obviously a error there. I'm going to just Google it real quick. Python 3 regex syntax. Regular expressions, example. So maybe it's like this, and then it's like this. And I think we need to do, maybe that's it. Let me try that. Okay, 147. Yeah, so that worked. All right, so this assertion is like, hey, when we call underscore underscore doc underscore underscore on a method that includes some documentation, which means includes a string as its first line, that string gets returned. So we can programmatically say, hey, give me the documentation for this method. And this R, a string placed, basically is like, it's true if this matches anything in the larger string, okay? All right, so now what is this? So we have something new. We've got a class called dog, and in that class there is a method called name that returns Fido. We've got a method called tail, which returns the string wagging. Prefixing a method with an underscore implies private scope. All right, so this is going to be a private method, a method that cannot be called by the outside. It can only be used within the class that we're in. All right, so we won't be able to call like dog.tail. And then we've got a method called password that returns the string password. All right, and notice it has two underscores at the beginning of it. That's kind of odd. And the private method tail only has one. So let's see what we can do with these. On line 145, test calling methods in other objects. Okay, so line 46, we have a variable rover set to dog. Okay, self.dog. We say assert equal, and we call the name method on rover. And remember, rover is an instance of dog, the dog class. And therefore, an instance of the dog class should have a publicly available method called name that returns Fido. So let's go ahead and give that a whirl. That's going to return quote string Fido. Let's try the next few. Test private access is implied but not enforced. Okay, so again, we've got a variable and it's set to the class, an instance of the class dog. Okay. Then we have this is a little rude but legal. Assert equal rover dot underscore tail. What is that going to return? I'm going to assume that because it's saying that it's not enforced, that this will return the string wagging, as it can be seen by the return statement there. Test attributes with double underscore prefixes are subject to name mangling. I don't know what that is. Maybe is that an actual thing, or it's just subject to mistake? What is name mangling in Python? Name mangling in Python is a mechanism that automatically modifies the names of class attributes, variables, and methods that start with two leading underscores and at one most trailing underscore, and at most one trailing underscore. This modification is done to help prevent name collisions in subclasses and to indicate that these attributes are intended for internal use within the class. Okay. So let's see. Test that attributes with double underscore prefixes are subject to name mangling. All right, so while on line 156, we've got a variable rover set to an instance of the dog class. And then we say with self assert raises something, password equals rover dot underscore password, underscore password. All right, so we're going to assume or presume that this raises an error. And because we are trying to call dot underscore password on an instance of rover, but remember the underscore is private. And so cannot be called from on the outside. So what do you think we get there? What type of error? I don't even know. I'm going to say type error, but I think that's probably wrong. Let's try to run the test and see where we're at. Mangling, attribute error, dog object has no attribute. All right, attribute error. Okay, let's see. That's correct. So we confirmed that when we try to call underscore password on rover, which is set to the dog, an instance of the dog class, we cannot. We get an attribute error. And that will happen when we try to call a method that has, at the beginning, 2 of these underscores, since they indicate that it's privately scoped. But this still is. Okay, so test attributes with double underscore prefixes are subject to name mangling, but this still is. So assert equal, we're on line 60 here, assert equal something, and then we call rover underscore dog underscore underscore password. Okay, name mangling exists to avoid name clash issues when subclassing. It is not for providing effective access protection. All right, so underscore dog underscore password, dog password, I have no idea. Let's see if it just returns password. It does return password. All right, so that was interesting. Let's get into one more file and do a couple more. But that was about methods, and that was interesting. I learned some stuff of that one. I've never seen, at least to my knowledge, this thing about scoping different methods or attributes, or I should say, scoping different getters, how to retrieve some data about a class using a method. Anyway, scoping that to be private or to be global, etc., using these underscore methods. So I haven't seen that before. I don't think that's a thing in Ruby. What else? There was something else weird up here. This overlapping method thing, all this stuff with the methods of the same name, that was kind of weird. Not too crazy. Yeah, I don't know, that was interesting. All right, so let's move on. Where were we? So we are now in about control statements. Okay, that's good. It's like fundamentals of programming, control statements. Control statements. All right, so this is going to be all about if, else, while, stuff like that. So we are in a new file called about control statements, a new class called about control statements, and a new test. Test if, then, else statements. All right, so some logic. If true, result equals true value. Else, result equals false value. All right, and we're going to say basically what do we think the result is going to be at the time of the assertion. My belief is that it's going to be true value, because this is always going to return true. True is always true. So there's never a way for the else branch to get triggered if this is the first if branch. Let's just confirm that's correct. All right, line 19. So we're moving on. Test if then statements. Okay. So we've got a variable result and it's set to a string default value. If true, result equals true value. Okay. So we have a result. I think it's going to get rewritten. I think it's going to be true value again. Because I think, yeah, we set the variable here to something different, but then we do get here and we do get here where it's overwritten. So my belief it's going to be the new value. Let's try that. Line 28. Yep, that was correct. Test if, then, elif, else statements. All right, so if false, the result equals first value. Elif or else if, it's like one if condition, the next is if condition, like you can chain them. If true, the result equals true value. Okay. Otherwise, the result equals default value. So my thinking is this is going to get skipped because false will always be false. Therefore, this never gets run. Then we get to here and it's like, or if you're true, and now that will always be true. So I think this line does get run, therefore setting the value of result to be the string true value. And when we do the assertion down here, I think we're going to see true value. All right, let me run it. We're on to 36. Yeah, that was correct. All right, test a while statement. Okay, so we've got I equals 1, result equals 1. While I is less than or equal to 10, the result has a new definition, and it's the result times I, and then we increment I by 1. And that's going to go up, so it's going to go through. All right, so let's take 1. Okay, so I equals 1, result equals 1. So then our first value of, I think it's going to be 1. All right, I'm just going to try to write this out a little bit. And then we increment, because result is 1, and we're multiplying it by I, which is 1 in this first pass through. Then we increment I by 1. So now I is 2, okay? And result is still 1. I is less than 10 because I is now 2. So the result now equals 2 times 2, which is 4. And then I gets incremented to 3. So I is now 3. The result is 4. All right. And now, okay, so the result equals 4 times 3, which is 12. Okay, and now we are greater than 10. So I'm going to assume once we're greater than 10, so we get to 12. All right, so at this point right now, result is still less than 10, so it runs. And the result of this is 12. So now result is 12. And when we get here again on line 33, this while is going to pass by. That nothing's going to happen. No more code is going to be run inside of it because I is not less than or equal to 10. Oh, shoot. No, I'm incorrect. That's I, not result. Okay, so we still keep going. So 4 times 3 is 12. I think maybe I just try to do this in my head. 36. Let's try it again. Okay, so result is now 12. All right. I is up to 4. Okay. So let's see. Result 12 times 4, 48. And now I is 5. So then we do 48 times 5. See if I can get this. 48 times 5. 240. I'll be surprised if this is actually correct by the time I'm done. 240. All right. 240 times 6. 1440. 1440 times 7. I'm using the Google Calendar, or man, brutal. Okay, the stupid Google calculator. 10080. 1080 times 8. 80640. 80640 times 9. $725,760. And then 725,760 times 10. Oh, that should be easy. I should just add a 0. 725,760 times 10. But just to round it out and make sure. 725,760. That's going to be 725,7600. Now this is going to be, I think, the value of result once we get here and I is less than or equal to 10. When I was 10, we were this value. Is that correct? Let's see. 725,7600. Let's run it. Moment of truth. 372 assertion error 72476. Oh, first of all, I typed it in wrong. 3628800. What did I have before? Yeah, that was wrong. I did this wrong. But whatever. 3628800. Somewhere we went sideways in here. But the point is, once you reach a condition where this is no longer true, it stops. It stops running the code inside. All right, so that is that. We're at 37 minutes. I think I will stop there and we will pick back up next time. But yeah, I hope this was enjoyable. Continuing to make our way through the cones. Let's see how far we are. We are now 30% of the way done, so not bad. Getting closer to our goal of completing all of these. Errors should never pass silently. I like that. All right, everyone have a good night. Have a good work week, and I will talk to you on the next one. Thank you. Bye.